So we need to use the limit comparison test to determine the convergence or divergence of the given series. We will start by letting a n be equal n over n plus 1 times 2 to the power of n minus 1, and bn equals 1 over 2 to the power of n. Now let's review the limit comparison test. So basically, by limit comparison test, if series an and bn are two series such that limit of an over bn, where n approaches infinity, equals c, where c is finite and positive number, so c is greater than 0 but less than infinity, then in this case both series will converge or both series will diverge together. Well, let's find the limit of an over bn. So the limit of an over bn, where n approaches infinity in our case, equals the limit of n over n plus 1 times 2 to the power of n minus 1, and this whole thing is divided by 1 over 2 to the power of n, and n approaches infinity here. Then this equals the limit of 2n over n plus 1, where n approaches infinity, and this clearly equals 2. So as you can see, the limit of an over bn is a positive and finite number. That means that an and bn behave alike. So either they both converge or they both diverge. Well, now let's look at series bn. So series bn equals the series the sum of 1 over 2 to the power of n, where n goes from 1 to infinity. And here this series is a infinite geometric series, because basically every next term is the previous equals the previous term multiplied by 1 over 2. And the common ratio of this series is 1 over 2. We know that for geometric series, if the absolute value of the common ratio is less than 1, and in our case the absolute value of 1 over 2 is definitely less than 1, that means that the series converge. So we know that the series bn converges. So now, since we know that series bn converges, and we know that an and bn behave alike, that means that series our initial series an, is convergent.